Okay, so welcome to the third of our seminar series from Yaşar Üniversitesi's Industrial Engineering Department. Today we are happy to have Dr. Özgür Akgün from Seminerleri University from Scotland. Özgür is a lecturer there at computer science, and his main research interests are in automated decision-making, constraint programming, optimization, and high-level modeling, as far as I know. And Özgür has his undergraduate degree from İzmir University of Economics, holding a double major, as far as I know, from computer engineering and industrial systems engineering back then. So he's almost one of us. And then he went on to get his PhD from Seminerleri University in Scotland, where he is now a lecturer. Today, we are happy to have him, and he'll talk about optimization problems using constraint programming in industrial settings, which we hope that it will be very interesting. Özgür, already you know some of the people here, some of the audience, but I'm proud to say also that this is one of the most crowded that we have this year, so no room for mistakes. And then he had a short survey that he posted, Özgür posted on our chat room, so he asks kindly to everyone fill that in. It's very, very easy, so that well, maybe you can do that while we wait for another minute. Özgür, I made you a co-host. We are, with your permission, recording this seminar, and then you can share your screen or presentation whenever.
Okay, I'm trying now. Can you see this?
Yeah, sure. And then during this seminar, we'll ask everyone except the presenter to shut their webcams off, please.
I thought I would be able to see my chat window, but I can't. So,
you cannot see the chat window?
It must be my fault. We don't normally use Zoom very much here.
Okay, so if you put your mouse down, you should see a menu where there's a chat button, participants, polls, and chat. Are you using the app or you're using the web version?
I am using the app, but I think I'll have to give up. I'll try for another minute.
Okay.
Show all windows. No. Anyway, I can see my own talk and I can see myself, so I guess that's going to be enough. So thank you very much. I shared this link in the chat. As Ramtuluja was saying, I appreciate all the responses. I can see the responses already, which is quite good actually. So I didn't know what the audience was going to be like. I wasn't sure. I know quite a lot of you are familiar with operations research, at least. Some of you know what constraint programming is, or you might have used it before. And most of you said you are interested in decision-making and optimization problems. That's great to hear for me, because that's mainly what I will be talking about. And I wasn't sure, I thought we would have students as well. Turns out we don't have students, which is...
We have graduate students, at least.
Oh, okay, so that's why everyone is PhD and beyond. I thought maybe we could have other students, but that's absolutely okay, no problem. So I'll start the talk, and I was going to encourage questions during it and interactivity, but I can't see the chat window. So can I suggest, if you have anything to point out or if you have a question, just unmute yourselves, and I wouldn't mind that. Or
let me be your eyes also. I have my eyes on the chat window, so if anything also comes up, people don't want to speak up but just write, I'll let you know.
Okay, fantastic. Thank you very much. So you can also wait until the end, and I would be very happy to have a discussion. So I don't have anything after this talk, so I'm happy to stay and have a discussion if people want to. Okay, so I wanted to introduce myself quickly, but I think Ramtuluja did that quite well as well. I'll give you my plan for this talk. I thought I'll introduce constraint programming, make everyone think about decision-making and optimization in general. I'll highlight a few application areas and a few active research areas in constraint programming. So some of these will be quite high level. I won't be able to go into a lot of detail with the application areas in some cases. And the active research areas bit is my understanding, my perception of where the active research is currently in constraint programming. So I wanted to include this to give a pointer to anyone who is interested. So I tried to fit quite a lot in a single talk, but I also don't want to sort of overload the talk. So I suggest you treat this talk as a teaser. And if you are sufficiently teased, I invite you to explore the topics further. And I would be very open to communication from anyone who is interested as well. So my name is Özgür Akgün, and that's actually quite a relief to be able to say my name correctly like that. That's one of the hardest questions I have to answer. When I live in an English-speaking country, they can't really say Özgür very well. So I ended up being Oz around here. But yes, my name is Özgür Akgün. I studied computer science and industrial engineering back in Izmir, at a rival Izmir University, I said, but since Mahmut Hoca was also mentioning at the beginning, that's the University of Economics in Izmir. There, I was quite lucky to take some courses from Cemal Dinçer, Arslan Örnek, I see Arslan Hoca in the audience as well, and Mahmut Ali Gökçe. So I started studying computer science and I learned some basic programming in my first year. Then in second year already, when I started a double major, I took an operations research course. And I think then I decided this is very interesting. I want to do something about this in my career. So I should say the professors I had there had a significant influence on what I chose to do as my career. So I'm very thankful for that. So I continued on doing more optimization related things and taking more courses, doing more projects in my undergraduate there. And then I started a PhD here. Yeah, so I graduated from my undergraduate in 2009. So I am getting old as well. I thought this was, this sounded like a very recent year to me until a few years ago. And now when I think about it, it's been 12 years already. Then I started a PhD right after that. I came to St. Andrews for a PhD. This is a very old university, which has, you know, very well-established research groups in a bunch of areas. One of that is constraint programming. So it is, I think now, it wasn't at the time, but now I think it is the biggest constraint programming research group in the UK, and it's probably one of the biggest in Europe as well. So within this research group, I started doing my PhD, and I then stayed on as an academic at the same institution. So as I said in the previous slide, this decision was influenced very heavily by the operations research courses I took back in Izmir. So I'm glad to be working in a similar area still. I just wanted to show you where I am. I never even measured this before, but Google Maps these days allows you to measure the distance as the bird flies from Izmir to St. Andrews. Apparently it's almost 3,000 kilometers, not quite. So if you want to visit us, there are quite good flights from Istanbul directly to Edinburgh, and that flight has made life a lot easier. Previously, there wasn't such a flight, and we had to take a lot of detours to come to St. Andrews. As I said, the university is a sort of old and established university. It's more than 600 years old. It has a lot of this sort of nice looking old buildings, Harry Potter vibes in the town. But we, being computer science, we don't really get to sit in any of these old buildings. In contrast, we have a very modern building, like this is our building, in one of the labs, and it is sort of shiny and new like you would expect. Okay, so a bit about me. So I wanted to do that at the start, and after this one, I'll swiftly get into the subject. So I suspected most of you would be familiar with operations research, but maybe not with constraint programming. So I wanted to start with talking about the connection between the two. So my decision to get into constraint programming was influenced by OR. And in this context, when I say OR, I mean linear programming, mixed integer programming, or integer programming. these two disciplines are very, very closely related. And in fact, they are not the only two that are related. There are other disciplines in computer science and in other fields. Maybe you could treat some of them as fields in logic or in industrial engineering. And these fields, these research areas, they are very closely related, and they can solve similar problems to each other. So one of them, this is one of the very sort of older research areas, is Boolean satisfiability, and this is mostly treated as a part of computer science, and it deals with only Boolean variables and a very specific kind of constraint on these Boolean variables. Essentially, you have your logical connectors, ands and ors, and you have to specify all of your problem in terms of Boolean constraints, Boolean decision variables, and Boolean connectors, Boolean operators. A more recent addition to this area is SAT modulo theories, which takes SAT, Boolean satisfiability, as a core, and on top of it, you're able to add new theories. These theories are things like, you could have a system of linear equations like you have in MIP and make it work together with a SAT solver. And this is gaining a lot of traction now. But at the end of the day, for us, for application developers, they can essentially solve the same problems. Answer set programming is another related paradigm coming out of logic programming mainly. And this, again, is able to solve similar problems. It has some unique features, answer set programming, but I won't be able to go into any of those details in this talk. The last one is meta-heuristics. I think this is also a very old and established area. So it is things like nature-inspired heuristics and colony optimization, taboo search, all of those things, genetic algorithms. So these are very useful because all of the methods I mentioned so far, including constraint programming, MIP, SAT, SMT, etc., they tend to be complete methods, as in they will find an optimal solution if they will find the solution if there's one, they will find the optimal solution given enough time. So they will be running systematic search to find an optimal solution or a solution if that's what you need. Meta-heuristics, on the other hand, they trade completeness for speed. So they can opportunistically get you to a good solution quickly, but there can be cases where there is a solution, but they can't find it, or they won't be able to find the global optimal solution, right? So the problem with meta-heuristics could be, will be completeness, right? So you may not be able to find a solution, or you won't know if a solution is optimal or not. But they are very useful, especially in an industrial setting, because the problems you solve in an industrial setting tend to be very large, and proving optimality of a solution tends to be difficult. So we often end up using meta-heuristics or a mixture of complete methods and meta-heuristics together. Generally, I'll say all of these fall into the general area of decision-making and optimization systems. So we have a problem of this sort. We have to make some decisions. We might have to optimize a certain optimization criteria, and we could use one of these tools to attack that problem. So constraint programming is related to operations research very tightly, especially in the use cases. If I had to choose one thing, I would say the unique selling point of constraints in comparison to, for example, MIP, is high-level modeling. And with that, what I mean is the modeling constructs you have when you're writing down a model are closer to the constructs you think about when you're specifying the problem, rather than the constructs being close to how the solver works. Okay, so I suspect most of you will agree modeling in operations research is a tough job, basically because the language you use is very restricted. So the only thing you have is continuous variables or integer variables and the system of inequalities, right? So a constant multiplied by a decision variable added up less than or equal or greater than or equal than a right-hand side. And that is the only kind of constraint you can write. You can write a surprisingly large number of problems using this fairly limited language. And if your problem happens to fit into this shape, life is really good. Like if your problem is something like a bin packing, and you want to say, if I added up all of my weights, it would be less than the weight I have available, or if I added all of my volumes, it would be less than the volume I have available. Then life is good, because MIP solvers are amazing if your problem fits into this shape. If it doesn't mean you can't use MIP, but you would have to start employing some tricks. And one of these tricks is like the big M method, for example, is a famous trick people will have to use if they have a certain kind of constraint to model in MIP. And the more you use these tricks, the bigger your formulation gets, and the harder it is for your solver to actually perform efficiently. Historically, constraint programming allowed more kinds of constraints. So, for example, you would get constraints like this decision variable multiplied with this other decision variable is less than or equal to another decision on the right-hand side. So everything could be a decision in that A times B less than or equals C. Or it could be A times B not equals C. A simple example like that one, I am sure you appreciate if you've done any operations research modeling in the past, could easily be an exam question, right? For a student to show their modeling skills in MIP. But in CP, you can just write that down and the solver natively supports that. So historically, even from the start in 1990s, constraint programming allowed more kinds of constraints in comparison to MIP. Recent research, and this includes some of my research, makes this high-level modeling even easier. So even higher level is the goal. And the added benefit of that is if you are able to go higher and higher in your problem description in terms of the kinds of tricks you have to employ, right? If you don't employ any of these tricks and manage to write your problem at a high enough level that is close to the problem description, you can now write a program like a compiler, which automatically converts a high-level model into an existing CP solver, as well as an existing OR solver or a SAT solver or an SMT solver. You could even extract meta heuristics out of them. So you start by writing a high-level, fairly short, succinct problem specification, right? We don't even call these models anymore because they don't make a lot of modeling decisions. They are high-level problem specifications. From them, you can extract all kinds of different formulations for different solving methodologies. And this has proven to be very useful when we are solving tough industrial problems. Okay, so that's setting the scene a little bit. And I now want to give you a bit more idea, some more ideas about how a CP solver works in the inside. And for that, there's a really good example we often use, and I'll use that same example. This is a simple puzzle. Okay, if you have a pen and paper, I'd appreciate if you give this a go. So this is the puzzle. We have the letters A to H, right? A, B, C, D, E, F, G, etc. Each letter appears exactly once in this graph. So you are supposed to place the letters down on this graph. Consecutive letters do not appear on adjacent nodes. So if two nodes have a link between them, have an edge between them, you are not supposed to put A and B or B and C next in those nodes. Okay, so the constraint is if there is an edge, you can't put consecutive letters on those nodes. Looks easy, right? I can't see the chat, but if anyone has some way of finding this solution. Oh, I found the chat. I now have the chat. Yes. So what do people think? Do you think this is easy enough? Do you think you can solve this if I gave you 5 minutes? What makes it difficult? So maybe I'll give up on the interactivity a little bit and I'll move on to the next slide where I will show you the source of this puzzle. So the source of this puzzle is a TV show that runs in the UK and it's been running for a very long time. It's called The Crystal Maze, in which there are a bunch of contestants. They get into mazes and they solve puzzles to get out of these, right? And if they solve puzzles within the allowed time, they will be able to progress further and their team might win some prize at the end. So this is a clip from one of the Crystal Maze puzzles. So on live TV here, and it's not very long. So you'll be able to watch all of it. And this is the actual puzzle they were solving. So someone enters the room, reads the constraints, and sees the object. So they have the decision variables laid out for them, right? And the values, potential values laid out for them, and see what you think, see how you think they are progressing. They have their teammates outside. They can shout instructions. They can say, put the B down, put A next to it, whatever, right? They can shout instructions. I think in this case, they were given 5 minutes, unless I'm mistaken, but this is a little bit cut down. This video is. So they so far haven't violated any constraints as far as I can see, right? There are no adjacent letters next to each other. By soon they will run out of spaces to put these things. But this is giving us some time to think about it. Maybe if anyone has an idea for like the first letter you would place, right? I don't want a full solution, but can you say, where would you start from and with which letters? Give another few seconds to think. Yes, E and F didn't work. And I think they failed at the end of this. Do we have anything in the chat? No, I don't think we do. So I think this is this is a good sort of demonstrator to show how a constraint solver works internally. And I'll go through this very quickly. Okay, so I sometimes use this example when we are teaching our undergraduates, but in that case, of course, we spend a lot more time on it. Okay, so assuming you are familiar with this sort of thing, I'll fly through this. So first question is, which nodes are hardest to label? I didn't get anything about this, but I guess people might think this is an obvious question. So I'll move on. These two in the middle, right? Because they are
nodes in the middle.
Those in the middle, they are the most constrained, right? So they have a lot of constraints on them. They can't be the same as, they can't be an adjacent letter there. So they are the hardest to label. So it would make sense for us, at least as humans, to start from the hardest decisions. And then you could think about the other thing, which are the least constraining letters to use. Would you be able to use a C, for example, which has 2 adjacent values before and after? But if you used A, then A would only have 1 adjacent value, right? So A would be the least constraining letter to use. So you could start by placing A and H here. As a guess, of course, you don't know at this point, but this sounds like the option which gives you the best odds, right? You'll be able to solve this problem potentially if you place A here, H there. Okay, so what happens if you make this placement? What happens? What's the effect of that? Oh, I wanted to highlight this. Some people might think, oh, why are you doing AH rather than HA? These are symmetric solutions to each other. So if you have this sort of a case, you can break the symmetry by arbitrarily choosing one of them. In this case, we know we don't have to consider HA. If AH doesn't lead to a solution, HA will not lead to a solution either, because they are mirror images of each other. So you can make some deductions at this point, right? When you place A and H, you can delete some domain values. So these were decision variables. The nodes were representing some of our decision variables. You can delete these values because they're adjacent values to the thing we placed down. And it brings us down to only having 4 values for the 4 corners C, D, E, and F. And some more deduction, adjacency, and appearing exactly once are the 2 rules we are using here for removing values. Okay, so here, sorry, I skipped over this too fast. So if you come to this place, you see at the top you have 4 domain values left. for both of the options, and at the bottom as well. On the left and right, you have the same 4 values and one additional, right? You have G on the left and B on the right. Because they appear exactly once in one of the decision variables, you know they have to be assigned to them, right? They can't be assigned to any other decision variable. So you assign them, do some more reasoning, and you come to this place where you actually don't have a clear choice to make, right? So you will have to guess, you'll have to make a guess. And what you do here is, in this case, we choose C to assign to the top left node. We assign that, do the reasoning, and moving on, we end up with the solution, and hopefully we have the crystal maze in our hands. We win this round of the show. So this is a demonstrator, really, of how a constraint solver works internally. A MIP solver, works by a very different process, right? So you have the system of equations, and you use Gaussian elimination, and then you produce some cuts and iterate in that way. In a constraint solver, the mode of operation is quite different. It basically alternates between being able to eliminate values from the domains of decision variables, and it does it until it cannot do that anymore. And if any decision variable has a single option left, it will assign that and continue. If it comes to a place where it can't do that anymore, it can't do any more inference, it will guess, right? It will do a search. It will essentially resort to searching, right? So choose one of the values, continue with the first step, do any new inference you can now do. If this doesn't work, if the thing you've guessed doesn't work, you need to be prepared to backtrack all the way back and eliminate that value from the domain and go on. So doing less search and more inference is, of course, good in that sense. It will make the solver go faster. Okay, so that's a very quick impression of how a constraint solver works. There are 2 steps in constraint programming, and they are generally seen as completely independent. And this is, again, very similar to operations research. We have the modeling step, which is capturing the problem in a formal language, and the solving step, which is not exactly, but very, very similar to what I showed you with the crystal maze example. So inference, search, an iteration between those 2 things. Someone in a research paper actually a while ago said, holy grail of computer science, and I think this is Gene Freuder's research paper. The holy grail of computer science is that user states the problem and computer solves it. Okay, that would be good, right? The user comes and says, I have this problem. These are the options. These are the things I don't want to happen, and constraints, and go on and ask the computer to find the solution to that problem. That would be good. Other people also say, programming should feel like writing an email or writing a short message to your friend or writing a novel. But of course, as we all know, this isn't really very easy. I'll show you how we think we are getting very close to that using constraint programming. And I'll argue that these sorts of modeling languages are the closest thing that we have at the moment to that goal of user states the problem, computer solves it. So here's a problem that is fairly small, and it's a toy example, but to demonstrate my point. The subset sum problem, it's a known NP problem, and the description of the problem is very simple. Given a set of integers, find the subset of those integers whose sum is 0. Right? You could parameterize it and make the sum something else, but the original description is this. So if you wanted to model this in a language we call Essence, and this is a constraint programming problem specification language, you would basically write this following program. So you first declare the language, and then you say, given a set of integers called nums, right? We give it a name here. They are called nums. Find me another set of integers called x, okay? Such that the x is a subset of the numbers, right? The thing we find is a subset of the thing we were given, and the sum of values in x is equal to 0. Right? So I claim that is very close to the problem description we started with. It isn't a formal language, so it isn't a natural language processing system at all. It is a formal language, but it is very, very similar to what we started with. What could be, when I claim this is similar, why is another language not this similar, right? If you wanted to model this problem in, say, a MIP language, you could do it, and it's fairly simple, right? You could write, I have a list of variables, and they represent, some of them represent the given, some of them represent the thing you're finding, and the sum is 0. But there are a bunch of different ways of doing this, right? Because the solver doesn't natively support the notion of a set. So you have to somehow model sets. And being a set means you won't have duplicate values in you, right? And you could represent the set in a bunch of different ways. You don't know the cardinality of X. You don't know how many values will be in X. So you could have, if nums has 10 things in it, X could be just one thing in it, or 2 things, 3 things, right? So you will have some Boolean flags to say which one is in the set, which one isn't in the set. Alternatively, you could just use a Boolean array and say, I have this Boolean array, each thing, if it's true, is in the set, then you have to model the rest of the problem accordingly. And so there are a bunch of modeling decisions to make, right? The moment you start making modeling decisions, before you even know what the values of nums are, you are actually introducing, well, potentially making ad hoc decisions, which will make solving more difficult. So what we want to do is we want to delay those decisions and make them automatically inside of a system. So here's an example input-output pair, and I think I took this one directly out of Wikipedia. If you give it -7, -3, -2, 5, and 8, the output can be -3, -2, and 5. And if you change the input, the cardinality of the output will change, of course, right? So this is a language that is higher level, closer to the specification of the problem, and doesn't require you to make a lot of modeling decisions before you can feed it into a black box solver or a black box system that can solve the problem. Okay, moving on. So that was a toy example, and I have so far shown you another toy example, which was the puzzle. And I'll jump all the way to the very high level, and I'll talk about some application areas. These are applications I've been, in most cases, I've been involved in. So there are real experiences behind these, and some of them are examples from the literature or from people I know who worked on these problems. So generally, CP application areas are very similar to the application areas of MIP, right? One of the very good areas where CP shines, so it's the best tool you could use, is scheduling and timetabling and rostering. This sort of problem, when you use a constraint programming solver, you can have much better performance typically than a MIP solver. But there are other problems like logistics problems, puzzles like the puzzles we've seen before, or workforce planning, which is also another area where you could say it is related to scheduling or rostering as well. There's a website called csplib.org, which I will actually include a link to in a couple of places. And I'll give you a list of some of the problems that are on this website. I want to publicize this website because it includes problem descriptions of problems from the literature, together with links to any publications about that problem. So it will have an entry for, I don't know, like I'll just mention the first problem there. There's a problem called the car sequencing problem. It is to do with a production line, and there's an entry for the car sequencing problem which describes the problem, some examples, and links to publications which use this problem and solve the problem in different ways. So it's a very, very good resource if you're interested in this area. I happen to be one of the current editors of this website. I'll say that as well, and contributions welcome as well. If you are working on an application, you can contribute. It is an open source library of problems. Okay, so I will now go through, I think, 6 high-level application areas of constraint programming I was involved in, and I'll briefly tell you about each one. And I think we will be able to expand on these later. If you have any questions, please do ask about these. So my descriptions might end up being very high level and not enough detail about these problems. First one is a school/university timetabling application. This is a fairly standard one. We have a timetable. We want to timetable either the lectures, so when the courses take place, or exams without any clashes. So we don't want to have clashes between students who take the same course, or we don't want to have clashes between the same professor who's teaching the same course. Or in the case of exams, it could be invigilators not having clashes as well. Also, we need to decide which room each activity will use. Without this constraint, the problem becomes a lot easier, because if you have infinitely available, like infinite rooms available, you can just spread out and have a lot of exams at the same time. This could be a limiting factor as well. There are many problem-specific constraints and preferences about this sort of thing. There could be things where, I know you will relate to this, a professor could say, within the exam diet, I would like my exam to be as early as possible so I have enough time to mark it. And the university might agree with this, because if it's a large enough course, they need more time to mark it, of course. A smaller course, which only 10 people take, could have its exam on the last day of the exam diet, whereas another course, which hundreds of students take, should have its exam quite early. Other problem-specific constraints could be things like a student who takes two different courses shouldn't have an exam on the same day, or hopefully the exams they take is spread across the exam diet as evenly as possible. One interesting idea we explored is, what about incorporating student preferences in terms of courses they want to take before we do the timetabling? So the typical thing people do is university administrators and department heads sit down and say, you know, these courses shouldn't clash because they are mandatory courses. These courses shouldn't clash because they are electives people are likely to take together. And they do that, which is an approximation of what the students want, right? So they try to guess what the students will want eventually. And then they do a timetable. Then the students are invited to choose courses on top of their mandatory courses, and they are limited by timetable clashes, right? So they can't take these two courses together because there's a clash. What if we collected some early preferences from the students? We sent them a survey and said, give me a list of courses you want to take. And then we did our timetabling such that we minimize the clashes for all of those students. This does, as you might guess, this does make the problem a lot harder, but it makes it a lot nicer for the students as well. So if we end up using, you know, if we end up torturing a computer for 2 days such that we find out a better timetable for everyone involved, maybe that is something we want to do. It could also be the preferences of academics, right? You could have academics who work on the part-time. You could have academics who don't want to do early days because they have to commute. So all of that can be fed into the system, and you could have a timetable that maximizes the preferences of everyone. So we are trying to flip the way you do timetabling. Okay, the decisions in this example are basically the time and place of each lecture or each exam. Constraints are mainly things like no clashes, and the objectives are spreading. In the case of exams, this is very important, also for courses, spreading the courses across the week, and fairness between academics and fairness between students, if you can afford that kind of computational time. Okay, so this is something that we are actually working on, and it is an interesting application which makes the problem of timetabling a lot harder. Okay. The second one is workforce scheduling. This happens in a bunch of problem domains. One of them is like a healthcare provider or a gym, where you have classes in a gym, and maybe in the morning you have a strength class, followed by in the afternoon some yoga classes and that sort of thing. And you want to schedule your workforce such that you will have enough courses, enough of these classes going on for your customers to be happy, right? So they will come, and some customers will want, yoga in the morning, so you need to have yoga in the morning some day of the weeks, and some customers will want, strength classes in the morning, etc. So you are trying to find a schedule for your workforce for when they are working, such that you maximize this sort of customer happiness. Okay, and the kinds of constraints you are limited by are things like staff capabilities. You might have staff which are essentially equivalent. So you have 2 yoga instructors, they could do the yoga course in the same way. How do you find a schedule, a rotation, such that they have a fair share between them, and you are maximizing the availability of your classes to your clients, and you're not increasing the amount of manpower you use when you do this? Okay. There are really interesting constraints about this as well. The simpler ones are things like rooms and availability of people and rooms and equipment. One interesting constraint is, I think, in modern gyms, people tend to have combined activities. So this is things like a cycling training followed by strength training followed by yoga. So they want short courses that are essentially fused together to make it one bigger course. So the cycling will be your warm-up for your weight training, and the yoga will stretch you after your weight training, kind of thing. But not everyone wants this. So they want the modern gym wants to offer individual courses, but they also want to offer them in such a way that the clients who want to combine them can combine them. Okay, so you want to find the solution where you are maximizing that opportunity as well. So the decisions are simple here. For your staff, who works when, and if there's a shift structure, what is the shift structure? The constraints are things like staff capabilities. That if they are giving a yoga course, they should have the required capabilities for that. And the objectives are generally fairness among your staff, because if you are perceived to be unfair to your staff, they will very quickly be unhappy, and you wouldn't be able to maintain this sort of a system. Okay. So another example, this is something I know a colleague of mine actually is working on in an industrial setting with one of the major supermarkets in the UK. And I think in Turkey this happens as well. You have, especially during the pandemic, this became very commonplace. You place an order to a supermarket and they bring your orders to your home, right? So as part of this, you need to do load truck assignment, which load will go to which truck. They have a limited number of trucks. Routing, which is mostly a solved problem. So we know how to solve routing problems efficiently, especially when it's on its own. So I put that disclaimer there because routing becomes a harder problem again if you combine it with, for example, the load truck assignment, or the next one, which is deciding when your drivers will work. So you want to organize your system such that you will match a predicted demand curve that you have in terms of how many drivers you have available and how many trucks you have available for different days of the week. So the decisions here are things like which load will go on which truck, the weight and volume restrictions. Temperature control is another one. Does the truck allow you to carry frozen goods, for example? Some of them do, some of them won't. And you want to do all of this whilst minimizing the cost and minimizing the delivery times, the lead time to customers. And of course, these two objectives may contradict. Right? You could be a lot faster if you invest more, but you want to minimize both of these things at the same time. Last mile logistics is similar, but slightly different to the previous example. You can in Turkey, I think you could think something like Getir. In other places, there are other examples, global examples like Uber Eats is another one that is specifically for food. Deliveroo they use bicycles more than cars. I think Getir uses motorcycles. Here we are trying to decide who will work when and where, such that we meet a predicted demand again. So it's similar to the supermarket one. Here we don't really do, the one difference between the two is we don't really do bundling very much here, because you have a small delivery that is very time sensitive. It is hot food that needs to be sent as soon as possible. So you can't really say, let's wait 2 hours and then we can consolidate a bunch of orders and do a single trip, right? You can't do that. And the solution often tends to be smaller vehicles, quicker journeys. So the placement of your delivery people becomes very important. and you are trying to find a solution such that you have enough people to cover the high demand times of the day, like lunch and dinner. And you also want to make sure you don't have a lot of people sitting idly just after lunch or just after dinner, right? So that is the core of the difficulty in these problems. You have your workforce, but you want to organize your workforce such that they are available for the peak, and then they are not idly sitting just after the peak or just before the peak. So the decisions again are similar here. Who works when? Constraints are things like meeting the demand and meeting contractual requirements you have to your employees. For example, a common case is your riders or drivers will have an 8-hour workday with a single lunch break, but they will give you flexibility about when they start work and how long a lunch break they will have. So that you could say to a driver, you start work at 2 p.m. today, and you will work for 2 hours, then take a long lunch break, and then come back and do 6 hours more after that. So you do this is your flexibility, such that you find a solution which meets the demand with minimum surplus. The next one, I think, is a fairly new development, and I think this happens in Turkey as well as globally. This is similar to like a Getir or Deliveroo style thing, but the difference is we don't really have any minimums of how much a rider or a driver has to work at all. So this is called the gig economy sometimes. So you have gigs, like a small bit of work you can do and you'll get paid for it. But you basically have an app on your mobile phone that says, it pings you if you install this app, and it says if you can take a delivery from point A to point B in the next half an hour, you will make $5 or something, right? You'll make a lot less than that. So in this case, you don't really have the problem we had in the previous example of finding work for all of your employees, right? In the previous one, you had to try to match the demand and not have a lot of idle workers after the peak period or before the peak period. But here in a gig economy sense, you could basically just stop sending them new gigs, right? Stop sending them new delivery requests. And what will they do? They will basically just go home, right? So this sounds great for the company. It sounds terrible for the worker, but it sounds great for the company. No minimums on how much the driver has to work. So it could just be a driver who does, 2 hours a day. It could be another driver who does more than that a day. Indeed, there are maximums on this in terms of sort of work contractual requirements. You can't really make someone work for, 20 hours a day, even if they explicitly consent to doing that. But there are examples, there are news stories about this. There are enthusiastic drivers who will work around these maximums by using multiple accounts, for example. So they could have two phones, and they could work on this one for 8 hours, work on that one for 8 hours. And it is the company's responsibility in most cases to detect these as well. So what's the decision problem here? We just send everyone a notification. If we have 10 drivers available in the area, we send them a notification. The first one accepting it takes the order, done, right? Sounds like happy days. Problem is, this becomes a game of using pricing, like you are paying them to do a single delivery to control the driver behavior. If you don't do this, what happens is, let's say I have the app, I have it open, and something comes up, someone else takes the order before I have a chance to even evaluate it, and this happens again and again. So I waste half an hour of my work time. Then I will be upset, and I'll go find a different job. Right? I wouldn't do this job if I don't have a guaranteed minimum income. So what happens is these systems try to use pricing to control the driver behavior. Also try to give incentives, like you get your first refusal in the first 5 minutes when you open the app. So they try to guarantee you get a job early on, such that you are likely to stay for longer. So this becomes a very, very complex problem indeed. It is a bit similar to pricing for flight tickets, but even more complicated and real time. So the decision isn't who works when, but it is more pricing and real-time task driver assignments, and you do this under a bunch of objectives. I realize we're coming to sort of almost the end of the hour. Should I just go on? I should maybe take 10-15 minutes to finish now.
Özgür, we are booked for an hour and a half. Usually try to limit our presentations into an hour, but we should leave some time also for questions. So maybe
Okay.
we can wrap up in 10 to 15 minutes. Yeah.
Okay. I should be able to normally anyway in 10 minutes. Okay. So one last example, and then I'll show you an actual model, because I realize all of these sort of more real life examples, they're high level, but I couldn't go into a lot of details in terms of how we would do this in constraints, but I will give you one final one about that. This is the last example before that one. And here we are trying to do a network design for electric vehicles. So electric vehicles are coming, right? They are the future. They are actually today. We've recently bought an electric vehicle. It's quite nice. The only problem is charging them takes time. You notice this after you get the vehicle. It is nice, and it's like all of this modern thing, but you are very used to being able to recharge or refill your petrol in no time, in 5 minutes. You drive for maybe you're doing a long distance. You drive for a couple of hours. You stop at a petrol station, 5 minutes, and then you can drive again. So the fastest chargers these days still take at least half an hour to give you anything reasonable. And that is very, very optimistic. You are unlikely to find the fast charger that's available every time you need it. So you can find another one that is slightly slower, and it'll take 2 hours of your life. There is a charger near where I work, and that will take 8 hours to charge up my car's battery. So that requires a lot of planning, right? You need to say, okay, are we planning to make a long distance on Thursday? If so, we have to charge it on Wednesday at this time. Right? So even at a personal level, it requires a lot of planning. So everything is great about these vehicles, except the charging time. And we've started recently using these vehicles in electric vehicles in public transportation, right? In Izmir, I think at least 20 electric buses they recently bought, and they are being used in the public bus network. So what they do currently is they've basically took the expertise of the existing bus drivers and the schedulers there to decide on something to do with these buses, right? They will charge them here, they will use them on these lines, but can we do it better using an optimization problem such that we design an electric public bus network which places the chargers strategically, uses the buses on strategic lines, carefully selected lines, like bus routes, and the actual daily schedule of the bus is found such that we maximize the use of these buses, right? Because they require significant investment. If the public is investing a lot of money into these, we should make the best use out of them. So the decisions are placement of chargers, planning the routes, and constraints are the range of the battery, speed of charging, and we are trying to maximize the active available use time of the vehicle. An easy solution, which is I think very close to what they do now, is to charge overnight. During the day, use it until the battery is completely flat, and then you go back to base and charge again for the next day. We think we can do much, much better than this. Okay, so I'll show you an actual model, and then I'll stop talking, and hopefully we can have a discussion. So the actual model I'll show is taken from one of the models in CSP-Lib, and it is called the social golfers problem. And there's a bunch of publications about this problem in the literature as well. The problem is specified as follows. You are the coordinator of a local golf club, and the coordinator of the golf club comes to you and says, we have 32 golfers who want to socialize with each other. They want to play golf once a week, and they always play in groups of 4. Can you come up with a schedule such that they play as many weeks as possible, and no golfer plays in the same group as any other golfer more than once? Right? So they want to achieve maximum socialization. They want to play with all the other golfers. A variant of this problem is this last one. So I'm skipping through this quite quickly now. Find a schedule for G groups of S golfers over W weeks, such that no golfer plays in the same group as any other golfer twice. So I'll use this one as another demonstrator of how close our description of the problem in English will be to our specification in the modeling language. So we use essence again. This is just a comment I wrote in the model. Right? We are given these number of golfers, number of groups, and how many weeks we are planning for. And in the language, you say, I'm given 3 integers. I define a bunch of golfer objects. One thing for anyone who's interested in symmetry breaking is that I'm not naming them. So I'm not giving them names like 1, you are golfer 1, you are golfer 2. I just say I have a bunch of golfers, this many golfers. This is important because it allows our tools to break symmetry, and then they can go a lot faster. So we have a single decision variable, a single decision to make. We say, find me a set of partitionings of these golfers. Each partitioning will be, in this case, of G parts, and each part will be S. Number of things in each part will be S. So you have 32 golfers, and you want to find 4 golfer groups. So you end up with 8 groups of size 4 for W weeks. That is the only decision variable you have, right? Single line, and you have a single constraint, which is achieve maximal socialization. So you say any 2 golfers play together at most once. And that is how you write the constraint. If I had a bit more time, I could go into more detail, but I just wanted to show you how succinct the problem description will end up being. One thing I want to highlight is that the schedule decision variable on line 15, we use it on line 20 as part of a sum expression. So we are summing over this decision. We don't know how many things will be in that decision, but the language allows you to have a sum expression over the decision. In a typical language, in like a MIT language, you would be able to have sums and for alls and exists kind of constraints, but they will always be on static lists. Right? Here we are able to do sum on a decision variable. So that makes it a lot more powerful. Okay, I had a bunch of backup slides, but I think I'll skip them and I'll go back to the last slide I have, which is just some advertisement about the tools we have here. And I invite you to have a look at these, the CSP, the problem library, and the tool itself that takes problems written in Essence is called Conjure. And I'm the main developer of this tool, together with a bunch of other people, of course. So I invite you to have a look at these. And if you have any questions about any of the things I tried to cover today, please go ahead. Thank you.
Thank you very much, Özgür. And now we will open up the floor for questions. If there are any from the audience, and please just go ahead and maybe ask.
Hi, Özgür. This is Arslan speaking. Nice to see you again after all these years, at least on a screen, not face to face, but at least on a screen. That's good. The only thing I want to ask you, still CP uses discrete values, no continuous variables now?
So depending on the solver, there are solvers which support continuous values as well. Mainly at St. Andrews, we do discrete values.
Yeah. I think that's the basic flow of the CP programming, I suppose, huh?
Sorry, I stopped that. I don't know. You could see it as that. I think if your problem has a lot of floating point decisions, but I think our friend Brahim would say those are the easy problems, right?
Yeah.
So if you have continuous decisions, I think it does become a bit easier. If all of your decisions are continuous, of course, you can just use a linear programming. So we have a few ways of supporting floating point decisions as well. One of them is using a solver that supports it. So there are open source solvers like G-Code and OR tools from Google. They both support floating point decisions, and they exist. But we focus more on discrete because there are more difficult problems there, I think.
That OR tools is not half as bad. We use that in one of the projects, industrial projects here at Hugo Boss, actually. You know a little bit about that. So not half as bad.
No, they recently won the competition. there's a CP solver competition every year, and they recently basically dominated the competition. It's a very good solver. So when I was talking about high level, you write a high level model and then you can target different solvers. You can write your model in essence and target OR tools as well. So you don't really have to be writing in the low level language. Of course, if you have the expertise to do it, maybe go ahead. But I should say we have some examples of like a professor of constraint programming writing a low level problem model and separately writing a high level model and using our tools to go to the low level. And the one we did automatically required a lot less work and was faster. So
can I ask a question?
Yes, please.
As you have realized here in the audience, there are people who are familiar with mathematical programming and modeling and use of Cplex, this and that. What you're asking, and I'll be the bad person, and I'm sure there may be some more people thinking that what you're telling is very good, very interesting, right? And you maybe kind of expect a question, but I have some of these mottos in my life. That one of them is, if something sounds too good to be true, it probably is. And this sounds a little bit too good to be true. And there's, of course, there are probably things that needs to be developed or improvements, or there's something that you are trading off instead of using that. So, or is it really that good? Because if it is the way that I understand it, is it's going to just wipe off some of the modeling techniques or other stuff, but there must be some, like these examples that you talked about. We never talked about the size of them and the performance of them. Can you give us maybe some sense what those are? So
I feel like I'm trying to sell a Çiftlik Bank shares or something.
Yeah, you didn't mention where we donate the money.
So this is all open source, and you can try it for yourselves, of course. I think you are right to be suspicious. So it is an ongoing research project, even though like I myself started in 2009, and there are other people who have been working on this longer than I have. The high level modeling parts are definitely ongoing research. And there will be cases with every new application, you can find something that we missed before. So it isn't as efficient as it can be, so we can improve it. And so I wouldn't say it is done. I wouldn't say if you have a new problem, you do it in this language and it will be the fastest in the world. I'm not claiming that, but I'm basically trying to claim this sort of setup, this architecture has the potential to be that good, and it is in a number of problem classes we've tried so far. So, and to answer your second question, I think it is slowly creeping up. Like languages which are established for a long time are slowly gaining these high-level features. So set variables are now becoming available in solvers natively. They weren't before. And solvers sometimes do this sort of conversion that we normally do for a long time. And another thing that is becoming very promising is using machine learning together with these systems, because you can start with a high-level single problem and go to different ways of solving it, but which one is going to be the fastest, right? So if you have a lot of time and a lot of computational resources, you can of course just experiment and find out. But we have a lot of past data, right? We have seen similar problems, similar instances, and we know MIP is good for this instance and SMT is better for that instance under this configuration. So can we have a machine learning driver that will make these decisions for us, tell us which backends to use essentially? And I think that can be the killer feature. We don't have that yet. So currently we just make it available. Like we expose all of these pathways, but we can't tell you which one will be the best one.
Okay, thank you.
I have just another question, if I may. I mean, whenever you use integer programming or linear programming, you use the same type of tools, right? And it's not solver dependent, right? Then, of course, depending on the solver, the commands you use might be a bit different, using, for example, GAMS or OPL, whatever. But it seems to me that the GP is completely, constraint programming is completely different. It's not modeling, right? It depends on the solver you use, right? If you use OPL, CP, then the command you use might be quite different than other languages. So how can we say constraint programming is a modeling technique? Is it a modeling technique, in fact, or is just a solver using the type of solver?
I think that's a very good question. The standardization, I would say, you have in integer programming is because it is very simple. You have a single kind of constraint, right? There isn't anything else you can write. And you have just two kinds of variables, continuous or discrete, and like linear inequalities. In constraints, what changes is you can have integer variables, floating point variables. You can have other kinds of variables in some solvers, depending on the solver. And you can have your normal arithmetic constraints, logical constraints, or what we call global constraints, which I didn't talk about today, as you know, I know you know. And the subsets of global constraints supported by each solver is different. So when you write a model for a specific solver, you have to know how that solver works, what it supports. Absolutely right. So it is part of the reason why we are doing this project, basically. The Essence language is a single language you write, and we have translation rules for every different solver, hopefully in the best way of writing it for that solver. So we call that process tailoring, actually. It's tailored to a single solver, like a given solver. So if you say, with the social goal-first example I gave, if you say use CPLEX, we can create a CPLEX model from that. If you say use Chuft, which is another constraint solver, we can generate a model for that. If you use OR tools, we can generate a model for that. And they won't look similar to each other, right? They will all use different features. But I think this, exactly the problem you're identifying, is one of the problems we are trying to solve. I agree, though. It is a shortcoming, but it can be a strength as well. It can mean that this solver can be a lot faster.
Yeah. Okay. Thanks.
May I continue, Mahmut Hocam?
Yeah, please.
Okay. Özgür Hocam, thank you very much for this wonderful talk. I'm not even a beginner in this area, so my questions will be basic compared to the previous ones, because I am trying to understand what is going on, what is CP. What I understand is the following. Please correct me if it is not correct. Instead of defining classical decision variables and constraints based on them, you define sets, the domains, where some of them are the Cartesian product of the others. And variables representing the values from the sets, okay? And then you finally write some quantified logical statements. And you are after the values of the variables that together make all the logical statements true at the same time. This is what I understood up to this time point. Okay, this can be done. This is a way of modeling decision problems instead of doing some classical modeling, as Aslan Hoca mentioned. Actually, this is for me not a modeling, but rewriting the problem using logical statements. Okay, my questions are the following. Does the order, please consider a solver where you write the logical statements. Does the order at which you write the logical statements affect the solution quality? I mean the runtime and the objective function value. And the second one, can you at least give us some sense or intuition behind these solvers? How come they can provide a solution which is better than the classical OR techniques?
So I think I fully agree. This doesn't feel like modeling. And that is part of the goal. So my thesis title was about automating the modeling process. So you write your problem description as close as possible to your problem. Exactly, I fully agree with what you said. So you rewrite your problem, not in English, but in this high level language called Essence. And then you don't do modeling. We do the modeling automatically. So we convert it to a particular solver. Well, when I say we, the tool does. The order of declarations doesn't matter. You can declare them in any order. This is fully declarative. So you are not giving it a operational semantics. You are giving it just a declaration. This is the decision I want. This is the constraints.
I am curious about the order because as far as I understood, it's a kind of algorithm that eliminates the possibilities for the variables. So maybe the starting point could affect where you are going to reach at the end.
Okay, I see. Yeah, I mean so that isn't very significant. So what happens is at each step, it will run constraint inference in a loop until a fixed point is reached, and then make it guess for the next step when it can't do any more inference. So the order doesn't really matter. So there will be internal activity-based sort of queues and queues of the next thing to do in the solver, but these are they won't be affected by the input ordering. Actually, there was a case where we thought, this is just an anecdote now, we thought the order made a big difference for a particular solver, and we tried to find why it shouldn't be the case. Turns out they make use of a random generator, and this isn't even the problem. The problem is they take the input and hash it and use it as the first sort of random seed. That's the default random seed. So if you just reorder things, they start from a different random seed. So the performance can be affected because of that. But I would suggest that's a bug, right? It shouldn't matter. The order of input shouldn't matter. And what was the last question? Sorry.
Could you please give us some sense, some intuition?
How they are better?
How they are better about the solver, the performance of the solvers.
They are not globally better. So CP solvers aren't always better than MIP solvers. Cplex is still a very, very good solver, for example. And OR tools inside of it has quite a lot of OR solving methods as well. So I'm not trying to claim that. I'm trying to claim a high-level modeling architecture is good because it allows you to go to OR and CP and SMT. And there are cases where CP is much better and you can make use of it then. Like, for example, scheduling. They can do better exactly because we have the global constraints for scheduling. So writing a constraint like 2 activities shouldn't overlap is very difficult in MIP, like as in it makes the solving get a lot slower, right? But in constraints, you have a global constraint which says this task and this task shouldn't overlap, which means they can be like this or like that, right? And basically because of the global constraint, it goes a lot faster in that application area. So it isn't globally faster than MIP.
Thank you, Özgür.
Özgür, are you gonna share the presentation with us?
Yeah, yes, no, of course.
Yeah, I would like to have the presentation.
Okay.
Yeah, okay. Adat Hocam, I think you have a question.
Yeah, a brief one. As far as I understood, the constraint programming is mainly referred to find the feasible solution, right, at the first. What about the multi-objective problems? Did you use constraint programming in such problems, or what is the situation in there?
Yeah, so I actually have a Turkish PhD student who's about to finish, who worked on a generalization of multi-objective called dominance programming. Gökberk Koçak, who's about to finish now. So I would suggest, if anyone is really interested, looking at his papers. We basically, yes, constraint programming started with solving CSPs, constraint satisfaction problems. Once you have a satisfying solution, for single objective optimization, you are adding constraints to say, find me a better one each time. Right? You run the solver again, essentially. This is the naive way of doing it. With multi-objective, you could enumerate the Pareto front, the efficient front,
Yes.
by finding an internal solution and then saying, find me solutions that are non-dominated by this one. So you are essentially pruning large areas of your search with every solution you find, you prune everything that is dominated by it. And it isn't only, so that's why we call it dominance programming. You can write dominance relations between your solutions, and it could be more than objective optimization. And it is a very, very interesting topic.
Thanks.
So you essentially find the solution, post the constraint, find another solution, post the constraint.
Thank you.
Are there any other questions? I'm just browsing through, but if I cannot see, just someone maybe speak up. I usually have a lot of questions when it comes to this constraint programming. I'm still a skeptic, but we'll try. Seems like a little bit of digging into is required to either appreciate or to talk more, and we'll do that. We'll do that. Özgür, do you know, or can you tell us some large scale, maybe, are there CP scheduling software or applications that are actually being applied? There are some really big scheduling problems, like in airline industry or this and that, and so is there any commercial applications of these things?
So there are a bunch of companies like Oracle. I know because I know a person who works there, has an internal CP team. Google has one, and the OR tools solver is just the open source part of it. Internally, they have a lot more constraint programming there as well. So there are specific, basically, constraint programming application companies. You may have heard of AIMS. I actually even have a book, AIMS. This is basically academics, and they started with MIP, and they are using some constraint programming techniques as well. In Europe, I think we have Quintic, which is a Dutch company, and they basically started, like, I remember I was a PhD student when they started, and they are now huge. They moved their operations to the US, and they solve all kinds of train scheduling problems, bus driver scheduling problems. There's another one called Satalia. I know that's a UK-based company. One of my office mates from my PhD works there, and they recently sold the company as well for, I think I just read this from a newspaper, so I know it is public. So it's like a 75 million pounds, I think they sold this company to a bigger company. So there are a lot of, and one of the clients they have was a supermarket chain, and they were deciding, which load goes to which truck, kind of thing. Yes, so there are a lot of large industrial applications. Definitely, this is very applicable, I think, to the industry. I don't. There's one in Turkey, Mahmut Hocam. You were telling me. What was the name of the Turkish company?
CP.
Not. Oh, was it the mathematical programming? Just
Yeah.
Well,
so, no. Okay. Yeah. So there are a bunch of other optimization companies I'm not aware of, at least. Companies that use constraint programming specifically in Turkey for.
Okay. I know, for example, I know Satalia and Quintic. Both of them use constraint programming. Definitely, Quintic sponsored a PhD summer school a while ago, and I was a PhD student when they did that, and they gave us a talk about the internals a little bit. And yes, they have a CP solver in there, definitely.
Okay, thank you. Well, any other questions?
Are you trying to hybridize MIP and CP? This is what we had done in the past with Jemalettin, but unfortunately we couldn't get good results. Well, it's as much as we dreamed. So I haven't personally done a lot of work in that, but there's a conference specifically for CP and OR applications you might have heard of. It's called CP AI OR. Alright.
So there are a lot of, if there's anything, it will be in that conference, I think.
Okay.
I actually had a slide for like different conferences in the area for anyone who's interested. I couldn't show you that one. But anyway, I'll share the slides with you, Arslan Hocam. You can have a look.
Thank you, Özgür.
It's a pleasure to see familiar faces and new faces. I feel like I visited Izmir now. We weren't able to come to Izmir for a long time due to the pandemic. So this is good. It feels like home.
Yes, that's also probably we should have said. Özgür is also from Izmir, so not only that he went to school here, but he is from the city. Okay.
Özgür Hocam, on behalf of the graduate school, I would like to thank you, and it was a pleasure to meet you in here. I hope in next days we can have you here and see you face to face, because the subjects are very interesting. I'm not from this area, but it is very interesting. Thank you again.
Thank you very much. Of course, it will be a pleasure when I'm there to visit. Yeah.
I would like to also thank you, department, for inviting you, and Mahmut Ali Hoca for moderating. Thanks everyone. And also attendees for being here. Thank you.
I guess with that final note, we'll wrap up today's seminar. Thanks everyone for attending, and that was I think as good as a closure that we're gonna get. So thank you, Özgür, and take care. Yeah, and then thanks everyone for attending.
My pleasure. Thanks for inviting, and I would be happy to talk to anyone who's interested. Please don't feel free to email me if you're interested about these things.
Thank you. Eğer izniniz olursa bir anı fotoğrafı almak isterim, ekran görüntüsü. Kameraları açabilirsiniz. Çok teşekkür ederim. Sağ olun. Öğrenci arkadaşlardan da teşekkürler.
Oo, bayağı insan varmış aslında.
Yüzleri görünce güzel oluyor değil mi hocam? Öbür türlü boşluğa konuşuyormuş gibi geliyor.
Daha dur YouTube'da yayınlanınca görsem popülariteyi.
Evet, sosyal medyada da paylaşabilirim değil mi? İtirazı olan yoksa. Tamamdır. Çok teşekkürler. O zaman şimdi bir resim alayım. Sanki alamadım.
Bence YouTube'daki kaydın özellikle bu kısmı çok etkili olabilir.
Evet.
Hepimizin
Tamamdır.
sessizce
Çok
dur.
teşekkür ederim. Sağ olun.